Welcome back, everybody. In this video, we're going to go over the beginning of chapter 1, which is section 1.1. Whenever we start a chapter, it's a good idea to go over the basics of what the chapter is about, just so that we know what we're getting into. Chapter 1 has a total of 10 sections, but we're only going to do the first 9 sections. The first one, 1.1, is about some basic terminology having to do with numbers like natural numbers and whole numbers and place value and periods and factorization, things like that. Section 1.2 is about the language of algebra, so the difference between a constant and a variable and combining like terms and how do you turn English into math, things like that. Sections 1, 3, and 1, 4 have to do with integers, which are positive and negative numbers and how you work with those. Sections 1, 5, and 1, 6 have to do with fractions, how you work with those. Decimals, usually people find decimals a little bit easier, and so that's only one section on decimals. The last two sections that we'll be covering, 1.8 and 1.9, have to do with properties of real numbers like the associative property and distributive property and others. But for now, let's just get into section 1.1, which is the introductory stuff on whole numbers. So the first thing is natural numbers are the numbers that you'd count with on your fingers, starting with 1. So 1, 2, 3, 4, 5, and beyond. Whole numbers are what you get if you take the natural numbers and also include 0. So 0, 1, 2, 3, 4, and beyond. When you have numbers bigger than 9, you have to have some way of representing that. Our system of numbering uses place value, so that if you have the number 517, that's different from the number 175. In the first number, the 5 represents 5 hundreds. In the last number, the 5 represents 5 ones. In other words, what place the digit is in changes its value. So some examples. The number to the right, 1,304. There's 4 ones, 3 hundreds, and 1,000, no tens. The second one, 596,814. And then the last one, 1,416,702. You'll notice here that we group the numbers into, or the digits into chunks of 3. Each of those chunks of 3 digits is called a period. And depending on where you're doing this, where you're from, you may also see, instead of using a comma for this, in some places they will just leave a little space between each of the periods to represent those numbers. So there are a couple of periods shown in the table below. There's ones, thousands, millions, billions, and trillions. Within each group, you'll see, starting with the ones, reading from right to left here, we have ones, tens, and hundreds. So the numbers shown in the table down here ends in 218, 200s, 1, 10, and 8 ones. The period to the left of that is the thousands period. So there's 1,000, 10,000, and 100,000. In the millions period, 1 million, 10 million, 100 million. Then in billions, 10 billions, 10 billions, 100 billions, trillions, 10 trillions, 100 trillions. So within each period, that is group of 3 digits, you have ones, tens, and hundreds before it goes up to the next period. Okay. So next, we want to see about writing out some of these numbers in words. So this first one is 1,078. You'll notice on this that 2 things. There are no hundreds, right? The 0 here is in the hundreds place, so we just say 1,078. There are no hundreds. Also, there's no and in here, so that's kind of a minor point, but you don't say 1,078, just 1,078. Okay, for number 11, let's try this one, 364,510. So let's put that out. That's 300,000. and then a comma. The comma usually goes in the same place the period ends. So 300, I forgot the 64, 364,000. And the comma, 510. In the next couple of examples, we'll go the other direction. That is, starting out with numbers written as words, we can write them out in terms of their digits. Here we have 412. That's 4 hundreds, 110, and 2 ones. Okay, next we'll have 11 million. And then 44,000. So this one, you'll notice that there are no 100,000s. There are 4 10,000s and 4,000s, and then 167. So 11,044,167. Last one, 24 here, has 11,471,036,106. If you have any questions on this, let me know. And also remember that the book covers all of these things as well. So if you need more detail and more examples, don't forget to take a look at the textbook. Okay, the next topic or subtopic that we're going to need is the idea of prime factorization and factors. So the factors of a number are the numbers that you would multiply together to make that number. In other words, or for example, 12 is 3 times 4, so 3 and 4 are factors of 12. Also, 2 times 6 is 12, so 2 and 6 are also factors of 12. For a lot of numbers, there are a variety of ways of writing down a factorization for that number. We're most interested, or often interested, in the prime factorization of a number, so we need to think about what is a prime number, and so that is next. Okay, so the numbers that are greater than 1 are all either prime or composite. A prime number is a number that has as factors only that number itself and 1. So the first few are shown here in the list. Another way kind of thinking of it is it possible to kind of break down the number using multiplication or not? So for example, 35 is what times what? Well, it's 7 times 5. This one, there's one way of breaking it down without involving 35 and 1. The number 19, though, 19 is just 19 times 1. There's no kind of more interesting way of factoring it. That is, any number is always equal to 1 times itself, so that's not that exciting. Numbers that are not prime have a more exciting way of factoring them. For example, of course, 18 is 18 times 1, yeah, sure, but it's also 9 times 2 or 3 times 6. Numbers that have more than one way they can be broken down like that are called composite. Numbers where there's only one way of writing it as a product are prime numbers. Out of all the prime numbers, there's only one even prime number, and that's 2. All of the others are odd. Not every odd number, though, is prime. 15 is 3 times 5. It's odd and not prime. Okay, so let's try to see on each of these if each one is prime or composite. 16 is 4 times 4. It's also 2 times 8. If you were thinking 2 times 8, you're right. 4 times 4, so it's going to be composite. 31 is prime. It's just 31 times 1. You can't break it down any further than that using multiplication. 49 is composite because you can write it as 7 times 7. So we've seen that there's a handful of ways of writing down many numbers, right? 36 is 12 times 3, or 6 times 6, or 9 times 4. The prime factorization for a number is the one that you get when all the factors are prime numbers. So for 40, for example, 40 is 8 times 5, it's 20 times 2, it's 4 times 10. But If we want to write it using just prime numbers, say 4 times 10, a little bigger, and 4 is 2 times 2, 10 is 2 times 5, then we can write 40 as 2 times 2 times 2 times 5. That's a prime factorization for 40. There's a lot of ways of showing your work for a factorization, but the final answer is always going to be the same. Here in this sentence, it says every whole number greater than 1 has exactly one prime factorization. That's what that means. So here for 40, if instead of thinking 4 times 10, if you thought, okay, well, let's say that that's 8 times 5. Well, 8 is 4 times 2, and 4 is 2 times 2. That'll still give you 3 factors of 2 and 1 factor of 5. In other words, the final answer is the same. Okay, we're going to find the prime factorization for each of these numbers next. 30 is going to be 6 times 5, and 6 is 2 times 3. That'll be 2 times 3 times 5. If you were thinking 10 times 3, that is okay. You're going to get the same prime factorization in the end. Your scratch work may look different, but it's the same answer. 36, we'll call that 9 times 4. 9 is 3 times 3, and 4 is 2 times 2. So there are 2 factors of 2 and 2 factors of 3. 105, this may take you a minute. This will be 21 times 5. And 21 is 3 times 7. So 3 times 5 times 7 will make 105. Writing this type of diagram to do a factorization is one that a lot of times students like, and so you're obviously welcome to use that. I'll probably call it a tree diagram. So if you hear me say that, that's what I'm talking about. There's more than one way, though, of organizing your work. So I wanted to show you how that would go using, let's use 36 for this. So the other way to organize the work is through repeated division. We're going to start with the smallest prime number, which is 2. So 2 divides into 36 18 times. And then 2 divides into 18 9 times. 2 doesn't divide into 9. What is the next prime number? It's 3. 3 goes into 9 3 times, and 3 is itself prime. So we're all done. The prime factorization is outside of these division signs. So of course, it'll be 2 times 2 times 3 times 3. Okay, whichever way you want to organize your work, either with the tree diagram or by repeated division, it doesn't make a difference to me. Neither is especially difficult once you practiced. So if you need more examples of this second way of doing it, let me know. Okay, so let's try a couple more examples. So we're going to do 240, 56, and 300. So take a minute, pause the video, and try this yourself, and then restart the video to see if you did. All right, so I've done 240. If you make different choices than me, it's okay. I chose to make it 24 times 10. 24 is 6 times 4. 6 is 2 times 3, and 4 is 2 times 2. 10, I broke down to 2 times 5. So we'll have 1, 2, 3, 4 factors of 2. And then a 3 and a 5. And that'll do it. Make sure that you don't miss any of the numbers or double count any of them. Okay, let's try 56 next. For 56, I can see that that's even, so let me divide it by 2. That'll be 2 times 28. 27 is 28 is 4 times 7, and 4 is 2 times 2. So we will have 3 factors of 2 and then a 7. For 300, I'm going to do the repeated division way, just so that we'll have another example. Starting with the smallest prime number, which is 2. 2 goes into 300 150 times. 2 goes into 150 75 times. 2 does divide into 75. The next prime number is 3. 3 divides into 75 25 times. 3 doesn't divide into 25, but 5 does, and it's the next prime number. 5 divides into 25 5 times, and 5 is a prime number. So we'll have 2 factors of 2, a 3, and 2 5s. Okay, that takes us to the end of this part on prime factorization, and also takes us to the end of this first video on section 1.1. We will continue and finish up section 1.1 in the next video. In the meantime, let me know if you have any questions, and then have a great day.